Alrighty. Good morning, good afternoon, good evening, good whatever time it is that you are up and about. Today we're going to walk through setting up essentially the same pipeline via a paid option, in this instance Databricks, and open source option, in this case Kubernetes. And so yes, we have to start with this architecture to work through. Basically, this is the full architecture if you were to do this in a large company, and you'd have your various different environments. In this presentation, I'm basically only going to show the production environment because I don't have multiple staging environments in this setup. But essentially, you would need to include your continuous integration, CI/CD pipelines, your continuous integration, continuous development pipelines for each environment. But in general, the setup is pretty similar throughout. Cool. So let's get started. I'll be working from a. You saw me. I will be working from the readmes that are in this GitHub repository. So let's get started. Find Azure Databricks. There he is. And then we just create one of these. We have the joys of using the resource groups that we already have. I'm just using my personal one within the company. Yes, and this is just going to be called paid. Oh yeah, in fact, it's going to be disruption prediction, because that is the actual product that we are creating. Probably should have started with this, but you'll see this in the other video. We have a I'm trying to do two things at once, which is not working. Display Azure Databricks. Yes, cool. Yeah, that's all fine. That's fine. Cool. Yes, and then we click create. And now we wait for it to deploy. Yes, so what I was saying, we have essentially, I'm using the Kubernetes example here, but basically we're using data from the Dutch train systems, the NS. We have historical data from a different data source, which I've forgotten the name of now, and we have the weather from OpenMeteo. And then based on these inputs, we're going to try to predict the amount of disruptions expected today using an XGBoost model based on what the weather is like, using like the historical data of disruptions that have happened in the past. And then this XGBoost model will be used, and then we'll have some kind of front end. And then the fast API is a Kubernetes specific thing. But basically we need to host the model somewhere so we can get the predictions from it using some form of REST API. Does it live yet? No. Probably we'll do some jump cut. We're back. Yes, so the resource has been created. Let's go to it, and then we can launch the workspace, which will open us in a new window. And of course, I need to sign in again. La 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 la. So at this moment, we have essentially created the resources necessary in Azure for our Databricks workspace, and we are now kind of setting up the workspace itself, which is then why we jump from our Microsoft Azure to the Databricks. First things first, we need to create a cluster. In the background, we are essentially saying we would like to use a Azure service to run some form of machine learning model, and like just general data munging stuff. Bunch of stuff that you can be doing. In general, the defaults are probably sufficient for what you're trying to do. In the future, if you're spending tons of money using what are they called, Databricks units, you might want to play around with the how many workers and stuff you actually need. Do you need 14 gig of memory and 4 cores to be able to do the thing that you're trying to do? But if not, this is most likely sufficient. So we wait for this to be created, and in the meantime, I remind myself of what the gosh darn I'm doing. So we've created a new cluster. Let us ingest some data then. We have a couple windows that give us different options. The data science and engineering one is sufficient for what we're trying to do. So we click the data one, we click that. So, my lord, everything takes ages. By the way, we are in the cluster that we just created here. Be aware that you can jump between different clusters. Cool. So let's add some data, shall we? In this instance, we're just going to upload some CSVs that we already have, but I mean, you can connect pretty much everything that you ever would want. Let's do that. And here we have the disruption data that we were looking for. Now we wait some more for load-in. Not too shabby this time, but we're only dealing with 12 megabytes of data. This, by the way, is a Delta Lake in the background with a Hadoop Hive layer, so you can interact with it, your backend using SQL or Spark, while still having kind of a blob data lake storage. We have some columns that we're going to use to predict stuff, mainly the amount of time that we had disruptions for, and I think we also select based on the reason something happened. Cool. Let's create the table. And then let's remind me what I'm doing. Okay, yeah. And so in the meantime, whilst it's setting up the data, we have this Jupyter notebook that we're going to incorporate. Ooh, hello. No, thank you. That's fine. I set up. Don't worry about that. In any case, we have this Jupyter notebook that we're going to include in our new workplace. Essentially, using MLflow to train, cross-validate, and hyperparameter tune our XGBoost model. And then in the background, we're going to use some Databricks functionality to create a REST API to then be able to query our model. Yes. So then reading in all of the packages, getting in the historical weather data. This is just using this API from OpenMeteo. So what you've got here is just essentially a request, Python requests from this REST API using a specific URL endpoint. And then we grab our data from our Hive warehouse that we are midway through creating or just creating. Do some minor feature engineering. We need certain things in certain formats for our model to be happy. And then we get the weather data. Also, again, creating features from this weather data. So we have the mean, min, and max of the temperature. And we have just the sum of the rain per day, which is then based on this group by for date. Cool. And then we merge, and then we assume that everything that is longer than 20,000 minutes is some form of outlier to not mess with our model too much. Yeah, we've got a validation and training split. Here we set up, it's quite an in-depth search space for the hyper-opt tuning, so like what is best for our model. This will then be incorporated into the ML flow setup in order to basically get out the best model according to what has the smallest RMSE. But yeah, we will see all of this coming out in Databricks, because Databricks has a really nice kind of experiment setup where you can compare all the models that are run using MLflow, using this autolog setup. And yeah, once you have this model, this function, you can set up your Spark trials and then specify how many things you're going to run in parallel. So we have arbitrarily 10. I mean, you can do this up to the amount of, is it RAM? Like if you have 10 cores, then you can run 10 in parallel. Not a developer, you may have noticed, more a data science person. In any case, here we set up our run. So with this start run, and then this is the name that we will see in Databricks popping up, we want to minimize with respect to this function. And then with the search space we saw earlier, which, essentially we're trying to find every single version of the hyperparameter that is the best according to smallest RMSE. And then that will run, and we'll go to Databricks to hopefully see this in action. So the reason I was talking is because the load-in times for some of these data can take a while, but now we have it. We see our Hive method or default disruptions, and this is just some info on what you can see. So you've got your columns, your sample data. All takes a bit longer than I would like, but I am someone who is somewhat impatient, it turns out. Didn't think I was, but we have since learned. Yes, Databricks has these three things, assuming that you're kind of doing different things. So if you're a data science and engineering person, you can kind of just hang out in here, and you're basically using these things to do data engineering, do whatever. And then if you're doing machine learning, you get these extra like experiments things, your feature store where your models will be saved, serving, which is in the REST API stuff we will look at the end. But for the moment, let's go to our workspace. We are in users, me, and then let's import our notebook that we just went through. Azure Databricks version, ML, blah, blah, blah. Cool. So here we have it here now, and then we can open this notebook in Databricks. And if everything is correct, fingers crossed, we should be able to run what we just talked through up until the point that we talked it through. So let's try that. Cool. So run all above. Yes, that's fine. So we're using the cluster that we created earlier, and we can see that there are cells running in this notebook. And you can also see at the bottom whether something's waiting to run or is actually being run. Where are we? So at the moment we're still loading in the necessary requirements, and then we've got there. And so, have we got there? Am I lying? In any case, I might speed this up because it's taking a while. Oh, by the way, these percentages are quote-unquote magic commands, which then means that you can directly talk to the terminal. Last command muted, that's nice. So you can directly talk to the terminal in the back end of this notebook. So this is the equivalent of opening a new terminal and putting in pip install. Cool. So, oh, it's nice. Yeah, nice that you get all of the information from like what was run and how long it took and etc. So we have now run up until the point that we can look at running our optimization. So let's do that. Bum, 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 bum. And so, because MLflow was written by someone in Databricks, the integration between MLflow and Databricks is very nice. And so you can already see this coming out in the sidebar of the MLflow experiments. Each of these are randomly named models that are being created in our flow. So we've got XGBoost models being the name of our kind of top level directory, which you can kind of see at the bottom here. There's no information on that, but each of these is then a version of XGBoost that has different parameters, and then we can later compare. So when we hit our 96 different models, yeah, we will be able to find out what the best one is. We can also look at this in the experiments tab. So this is then from ML. ML is then just the name of the notebook that it was run from. Thank you very much, Databricks. And then also here, this is kind of like the parallel thing that we were seeing in on the right-hand side, but then with more information. So you can look at the table, which is then just, this is the model, and this is some information about it. This, by the way, is verbatim what you would see in the MLflow user interface if you were just using this locally. But yeah, it's very nicely integrated into Databricks. Yeah, and then they have this kind of philosophy of how you should package your models. So these are all files that you'll get per model, where it will basically explain what the model is, what inputs were used, what version of it is, and then, yeah, the Conda environment for it. XGB is the model saving format for XGBoost models, so you can read them in once you've trained them. And then, yeah, this is just a Python environment, so we have not only what Conda was used, but also just generically what Python version we used and where we got the requirements from. And then, yeah, this is just our regular requirements text if we're using pip instead of Conda. Yeah, and then on top of this, we get our feature importance weights. So these are our features, and then what is then more important. I believe, yeah, I need to double check what feature importance algorithm they're using in the background as a default. I would assume Ginny. Yeah, I'm not going to say anything. Yeah, and then this is the plot of this. So the bigger this number, the more important the feature is in predicting your disruptions. Yeah, it's annoying. I should have checked that. Yeah, I'm not 100%. Yeah, in any case, these are the parameters that it was training. Probably not all of them, but it's been a while since I wrote this code. So looking through the different parameters we're optimizing, hopefully by this point we also have finished our model runs. So all of our experiments should be here, which looks good. Also, by the way, the data set is saved in each of these models too, so you have both the validation and the data set, which is kind of handy. Cool. And then what I also like on top of this, you do also get this in MLflow if you use their UI, but it is nicely incorporated into Databricks. Is yeah, you can look at the training that you just saw. So for us, let's say we care about the max amount of depth in the trees and the number of leaves per branch. Yeah, per branch. And then we care obviously about our RMSE. Maybe in fact we care more about the RMSE and the. In fact, let's have both. Sorry. That we care more about that we have the RMSEs per model, and so we can kind of quickly see which model is the best. So We know that the smaller the RMSE, the better the model. So the Lyrical Zebra 546 is the best in this instance, it turns out. Yeah. So what is this model basically? Is in the question. So we have where are we? Feature importances being still temperature mean, and then the metrics that we saw. One with the 156.1.2 and 156.3.8, and then the parameters that we care about. Our learning rate's about 0.05, which is kind of expected, 0.06 I guess. Maximum depth of the things is 3, which is nice, not too complicated of a model. The number of leaves, quite high. But yeah, so we know that we validated, and in theory then we have a model that should generalize well to new data, and be able to be used to do stuff. Ooh, that's not what we want. Oh, there it is. Yes, so now we go back to our notebook, which is struggling for some reason. Ooh, I don't want to do that. Let's just go to the regular route because I am being daft. Right, so we go back to our notebook again. We know, oh, by the way, this is still live because the cluster is still green. So in theory, we can just pick up from where we left off. So we've run now all 96 of our trials. They all succeeded, which is handy. And now we just kind of want to see what is the RMSE of the best run. So in this instance is 1561, and we kind of saw that already from our looking at our experiments. And then yeah, we just want to print out what is the best run. This is just what we already saw. We have our, where are we? Should be 3 or something for our trees params. Where are we? Yeah. Got our max depth, our number of leaves. I missed one apparently. No, it turns out the one that I thought was the best was not. In any case, we programmatically we grab the best, so we know that we are good, and we're going to register our best model. So it's just the ID that is here. It's annoying, it doesn't scroll in the thing that you want it to. In any case, so this is then the run ID that we're pulling. This is basically just essentially a sort of dictionary that you can then specify the thing to get the output. And we're going to say, we're calling it a model, our model, the disruption prediction, and we're going to specify that this is our best model for the moment. So let's do that. Oh, sorry, I did the shortcut, but basically if you click Shift Enter, it's this equivalent of running the cell and going to the next cell. Cool. So in doing that, we will essentially register our model. It takes a few seconds. Adding the delay is just kind of to stop us from being too sad when it's too slow. But yeah, so now in our registered models, sorry, it's models there. We see our disruption prediction. We have our version number. Currently, we've not specified that it's in production yet, but essentially what we saw earlier is now been registered, so people can actively use this model to request information from. And we go back to our notebook again. It's funny that it's struggling a bit this morning. I don't usually have that issue. Yeah, and go back to where we were in our notebook. So there was our best run. We've got the thing done. It's got all the tags and the model registration and stuff, which is very nice. Yeah, and now we can just try it out. We have a model that's there. So yeah, let's grab our MLflow client. In fact, excuse me, this is pushing, so we've created the thing, which we just saw in models, and we want to say whether or not it's a quote-unquote model that's in staging or a quote-unquote model that's in production. If it's in staging, then it's still not ready for the world to kind of use. It's more just used for testing the model out and seeing if it's okay, if it's reaching the minimum requirements to be used. But in this mini tutorial, we're just going to say that it is good for production. And then the code for this is here. So we just grab the MLflow client and just specify that it's now in the production stage, specifying the specific model version, which, yeah, I mean, in this instance, just version 1. And if we go back to models now, we see in production version 1 is being used. It's just a nice way of keeping track of which model's there and the kind of model workflow that can be used, and you have all this metadata related to the models you're using in case you want to roll back or for model governance and data governance kind of stuff. Yeah, and then last but not least, we're going to pull in the model that we just saw, which is then in production, and then just see what the RMSE of the output is based on the prediction. So we have our output. So we've trained, cross-validated, and pushed a model to production, and we've then gone and pulled the model that's in production and used it to make a prediction, and then looked at the difference between the prediction and the between the test and the quote-unquote holdout set is what we're using essentially, and the prediction based on the holdout set data, and then the difference, which is in the RMSE. Cool. And then I frantically go back to my README to remember what I need to do next. Yes, so now we've kind of looked at the experiment results and finished working through our notebook. Now we're going to use our model for inference. This setup is basically creating a REST API endpoint for using this model. So at the moment we can use our model within Databricks, but let's say we have another service somewhere that wants to use our model to predict stuff. So we're going to create a new endpoint, which is then just, as I say, like a mini REST API that you can then send data to and get the predictions back. This doesn't super matter. It's just to distinguish it. Disruption, prediction, model. We're going to use, so this is just setting the size and stuff for the trained model's REST API. So before we used a lot of requests and stuff to make the model, but because we don't expect too many people to be calling this endpoint, we can use the small units amount. And scale to 0 is basically, if no one's using the model, we want it to not cost us money. So essentially scale the compute and whatever to nothing. So create endpoint. It will then do some stuff. We may need to do a cheeky jump cut again. Jump cut back. Okay, so our model has been, our model endpoint has been created. It's also nice that Databricks gives you metrics on how many people are using it, and how slow it is and how much computer usage, etc., etc., etc. Cool, but we want to use it now, so we can click query endpoint. This gives you a couple options. This is the curl commands to send data to it, assuming that your data is then in a JSON format that is correct, or some Python code to do so. I've grabbed this already and put this in this endpoint. You can see I've run this a couple times now because each time I create and destroy Databricks endpoints, I need a new URL. But prior to doing this, what you may have noticed is that it assumes that there is a Databricks token in your environment. So first we need to create that. So we can go to our user settings, generate a new token, and what's it for? It's for disruption prediction. You can of course name it what you fancy, but it doesn't super matter. It's just for you to know later. And then we're going to throw this in our .m file, and we need to call it this, of course. So, bum, bum, cool. And what isn't the exact same in this setup, by the way? Databricks assumes that you have done the correct setup for your .env. Where am I? Excuse me. Serving. That you have correctly set up your .env for your credentials to be found. So they don't include in their code directly pulling in this this token. In this setup, I'm just using python.env as the name of the package. And what this does is it will load a .env file that it finds recursively backwards. So in this instance, it's searching through all of these folders and files, all the different .envs, and it will just pull everything into your environment variables. So in theory, we can now run this locally. This is not in a Databricks setup at all. This is just on my local computer. Cool. So we've loaded in our environment variables and so on. And then we're going to, I of course need to update the URL. Oopsie doopsie. There he is. Bum, 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 bum. Oof, it's longer this time. Exciting. Oh, because I called it something different. Oops. In any case, we come back. We have a couple functions, and then so in this moment we're just reading in the functions, and then in this instance I'm saying we have temperature mean of 10. In fact, it's a bit boring, isn't it? Let's make it the minimum be 8 and the maximum be 12, and then there was no rain on this day. And then, yeah, hopefully we can call the REST API to give us a prediction, which it does. So that's exciting. Yeah, so according to our model, today we will have 1,275 minutes of disruptions in the train network. So this is all well and fun. You could say that we've kind of finished our tutorial here. Oh yeah, and then for cleanup, we're just going to delete stuff. So that exists. We queried our endpoint, we got a result. We also see that we did use it, in fact. See it in our outputs. Nice. And then we can kind of see the events. Yeah, that the thing was created correctly, entered a ready state and so on. And we can see our logs. So at this moment, it's using GUnicorn. That's interesting. Yeah, so there's essentially a thing running here, and yeah, it's good. Alright, cool. Yeah, so we've kind of finished what we were doing here. We're going to go back to our setup and, yeah, just delete it. Don't need that anymore. Thank you very much. And, yeah, that's the Databricks version of this. Setting up a model, setting up a workspace, let's just have it here. Setting up a Databricks workspace, launching the workspace, creating the compute stuff that you need, ingesting data. In this instance, it was just uploading a file, but you can do many different options. Grabbing the notebook that we wrote, you can also just write this directly in the Databricks notebook format. But yeah, it accepts Python Jupyter notebooks, like flat. Looking at the experiment results in the different tabs, we created a model REST API using the use model for inference setup. Yeah, and then we ran and tested the local environment. And yes, you can also create a dashboard which then shows you a nicer version of our test endpoint, essentially. And yeah, don't forget to delete your cluster and workspace.